All right, ladies and gentlemen, here's something from my flat earth buddies to ponder on. Uh, to believe, at least those of you who believe we're still, we're sitting still, you know, the dielectric medium or the dielectric plane, the earth is still. It's the sun and moon are rotating around us. Well, the reason I would go against that is knowing what I do about electromagnetic induction, the way a transformer action works. See, a transformer action, the reason you can't transform a direct current is because it creates a static displacement. It creates 180-degree longitudinal displacement between the two terminals of the winding of the coil. It's 180-degree displacement right there. And so between the terminals. Now, before we can have any inductance, okay, we have to have, see, the electrostatic voltage and the magnetic amperage are 90 degrees out of phase here. See, so this oscillation is going on between the primary and secondary windings. And we just have on a direct current circuit, we just have a linear displacement of 180 degrees. Same axis, on the same axis. Now, in an alternating current, it is as well. It's longitudinal displacement, but it keeps reversing, right? It keeps going to a maximum, back down to a negative, to a maximum negative, back to zero. So it's continuously collapsing and changing polarity. We have to have a changing magnetic field in order to induce voltage, electromagnetic induction. Okay, now in a direct current circuit, we have a linear 180-degree displacement in one direction. Right now, on a single phase winding, we also have that's 180-degree displacement between each terminal, each lead of the winding, each end of the coil. Those leads are 180 degrees displaced in the physical 3 dimensions. Okay, and so now when we have a direct current which has no frequency, a direct current has no frequency. So that type of situation creates a static magnetic field out around the coil. It's stationary north and south pole. It's not oscillating. It's not moving. Right? So it's not changing, continuously changing. Now, you ever notice how when you're sitting in your car, dead still, you feel zero force, zero G force when you're sitting dead still? Okay, well, you can be going down the road at 70 miles an hour too, and you'll feel, as long as you're at a steady pace, you won't feel any G force either. Right? The only time you're going to feel any force is when you accelerate or decelerate. When there's a change, just like we have to have this changing magnetic field up here in a transformer, it has to be constantly reversing polarity. Well, before there can be any force induced, well, like I said with the voltage is the difference of electrostatic potential between two physical points in 3 dimensions, such as the terminals of a circuit. Now, if they're both sitting at the same, imagine these being, metal rods, both at 120 degrees. Now, if I make contact and close the switch, if they're both at the same potential, there ain't going to be no energy transfer, because you can't go someplace you already sitting, right? Obviously. If they're both at 120 degrees, there's no drop, right? Now, if one's at 100 degrees and the other's at 20, we got a 20-volt drop, right? And direct current sitting out. Remember, direct current has no frequency. Direct current is a longitudinal displacement without the magnetic transverse component. It's a And like I said, the magnetic field and the electric field are 90 degrees out of phase from one another. There are different modalities. There are two different modalities. Electric power or electricity, whatever, however you'd like to term it, is, now you can't just have a permanent magnet and have electricity. And you can't just have a charged capacitor. That ain't electricity either. You know, it's only when those two field modalities come together that you get electric power. And that is a physical component, which is always kinetic. You know, with the generator, again, we got a kinetic input. And in order for anything to be kinetic and have rotate, it must have magnitude, physical mass. So obviously, the kinetic input is the magnetic component. It has mass, magnitude. That's where the word magnetism comes from. Magnetism is what created space and time. It's magnetism is responsible for space and time. Okay. Now, because when there ain't magnetism, when there ain't no physical component in 3 dimensions, you know, just like we showed you with the rotor in an electric motor, you know, the reason why when you close the starter, the rotor's automatically at, the stator is automatically at 60 hertz, 3600 RPM, and that's moving along. Now, the reason it is instantaneously at that frequency is because it's metaphysical. It's a metaphysical voltage signal. It doesn't have to contend with drag and time and inertia and all that shit, because it's metaphysical. However, the rotor, if I can find my damn drawing here, the rotor, this is the generator. However, the rotor right here, this is the rotating component, this is the static component up here. The rotor in an electric motor must lag behind. The donkey must lag behind the carrot, right? There must be a certain distance in between the donkey and the carrot. Okay, now that's the phase lag, and it must be there. That's what, you know, slip. That's negative slip. As far as with respect to the physical component and the metaphysical component, the static component. Now, a generator is a positive slip between the physical component and the metaphysical or static component. Okay, so now talking about reduced voltage starting, I showed you Y delta starting method. You know, so we start in the Y configuration. And all you electricians know what a Y configuration is. My old lady brought it out for me right here, bud. Got a good old lady to indulge in my obsession. Right, so here we got a Y configured. You know, this is 3-phase distribution. It's 3-phase generator, what I'm depicting right here. Now, in practice, we always have, you know, it's not a single. So a phase, what a phase is again, we have 1 hertz is 1 360-degree rotation of this rotor inside the stator's field. Okay, one rotation, 1 360-degree rotation is 1 hertz. Now we can chop that cycle up and subdivide it 3 times. If we displace the windings 120 degrees, 120, 120, and 120, that's 360. Right? So now, why do we start in Y? Now this is delta configuration. Now this is our run. We start in a Y, and we change over to a delta configuration to run. Now why? Well, I explained to you the inrush current was the cause. That's the reason we do a reduced voltage starting method. It's due to the inrush current that is created until the rotor can catch up to the metaphysical component, the voltage. Okay, so now even on a Y-configured system, from phase to phase, we have a phase-to-phase voltage, right? That's 480 volts. I've depicted it, you know, brown, orange, yellow. That's the standard for, 480 volts. 480 volt to phase. However, in a Y configured system, we have a phase to neutral voltage as well. And so that's what the windings are experiencing. It's because these three windings right here are all tied together. They're all shunted together. At 0.0 potential. The dielectric plane is dead center of the generator. Dead center of the phase wind. All of them. Right here. This here. That's your neutral point right there. Okay, that's the 0.0 potential right there. And so now from here to here, we have 480 volts from phase to phase. However, if we go from phase to neutral, or phase to zero, we have 120 volts. Okay, so we've got 2 points of perspective, or 2 points of reference in a Y system. Right? We have, again, at least 120 degrees displaced from one another. Inside the 360 degrees of empty space or nothingness. It has been enclosed off by the stator. Now, the windings create a boundary. The winding and the phase conductors, the conductors create a boundary which traps the voltage signal, metaphysical voltage signal. It isolates it. Can't get out. Now, if we were to just, spin the magnet, spin a permanent magnet with no stator there to enclose it off, then it would just reverberate longitudinally out in all different directions of potential. Metaphysical potential would go out in all different directions, just like dropping a rock in a pond, concentric circles, right, out in all different directions. However, when we boundary that off and boundary it off with, stator windings, between the stator windings and the conductors, we have isolated a voltage. See, you ain't got no voltage unless you got 2 points. Voltage is the difference of electrostatic potential between 2 points. And before you can have a difference of anything, you have to have 2. So the primary function of the generator is to create a phase displacement. Now, again, in a single phase situation, you have an in-phase displacement of 180 degrees. That's why you can't produce 360 degrees of rotational motion with it, because you don't have a phase-to-phase voltage. You have a in-phase voltage, which is simply oscillating. At 180 degrees, positive, negative. Now, when your magnetic field is at its maximum, obviously your electrostatic field is at 0, and vice versa. When your electrostatic field, when your voltage is at its maximum, your magnetic component, or your amperage, is at 0. Okay. Now, so here's how, the reason we get a reduced voltage from this is because we have a phase to neutral voltage, which these windings are experiencing as this, we have a kinetic input here. We have a kinetic, magnetic, physical input, and a static. The metaphysical potential is collected on the static end, the output. Again, in an electric motor, this is exactly the inverse is happening. So there's a positive slip, or not a phase lag, it's a positive phase displacement between the physical input and the static, or the metaphysical output in a generator. Positive slip. Okay. Now, but that's why we start in Y. Now, see, we don't have, in a delta configuration, we don't have a neutral. We don't have a 0 point. We just have a phase-to-phase voltage. And the reason there's voltage, between A and B is because they're at different potential. You know, as that magnetic field turns, it cuts across these windings at different times and at different intensity levels. The intensity levels experienced by the windings is always fluctuating up and down continuously. And so when A's sitting at one potential, B's sitting at another potential. So I want to sing, and to just demonstrate to you. Well, I can't demonstrate it to you because I don't have the material. But I once seen a physics professor on YouTube. I forget his name, but he was boiling a block of ice. Now, how in the hell do you boil a block of ice? Well, you can boil a block of ice by finding something that's colder than the ice. The difference of potential, such as liquid nitrogen, something that has a colder temperature than the ice. Then, as long as you have that difference of potential, a negative difference of potential, then you'll be able to boil a block of ice. It's all about relativity. That's not what Einstein meant, perhaps, but what Mr. Gordon means by relativity is, I think Mr. Watts said that, if you had just one ball, one empty, not one empty, but one ball, one globe, blue globe, or blue rubber ball in the middle of empty space, you wouldn't be able to tell if that ball was moving or not. You couldn't tell if the ball was moving or not if you just had one point, just the ball in the middle of empty space, and you didn't have 2 points of perspective. You didn't have a still point of perspective. You couldn't tell if it was moving or not if you didn't have 2 points of perspective, or 2 points of fuck, words slip me. But anyway, you get your point, right? You got to have 2. You wouldn't even be able to tell if the fucking ball was moving if there wasn't 2 points. And then if there was only 2 points, you wouldn't be able to tell whether the balls was moving away from one another or apart. You wouldn't be able to tell which one was moving, which one was still. So you gotta have 3 points of perspective. The 3, the triune God, which I ain't going there with it. But 3 is the electrostatic potential, matter, and magnetism. That's 3. That's a triune situation there. 2, it's counterbalance. See, when the closer, the ether has 5 stages. The dielectric medium has 5 stages. I think it's 5 stages, but first is a plasma. It's a lightning bolt. Right? And then it goes from a lightning bolt to a gaseous body, like a cloud. And then, oxygen, whatever. That's the second state. The ether, there's the ether, the dielectric medium, nothing. Then there's plasma, lightning bolt. Then there's gas, such as cloud, oxygen. And then I'm missing one, but water, then matter. And the closer you get down towards the point zero potential, the harder your material gets. Diamonds are found deep down in the earth. Anywho, that's neither here nor there. So with a delta, so we want to start in Y. We start the motor in the Y configuration because we got a phase 2 neutral voltage. Okay. Now, so what I was getting at though, with that block of ice is we got a free energy situation going on with every heat exchange. There's an over unity situation going on there where they're running Freon, the chemical is being run out, it's at a ungodly cold temperature. And the thermal energy, because there's a difference, because it's so cold and the atmosphere is so whatever the temperature, the atmospheric temperature is, there's this difference of potential, and so it absorbs the thermal energy right from the ambient area around the heat exchange. Uh, that's over unity. It's not quite over unity, but it's so this is what cold fusion, um, a negative. The only thing we got to do, free energy, which I'll probably get my fucking brain blown out for this, getting blown out for him. But free energy is simply a matter of, we need to get at a negative. Our atmosphere is at one electromagnetic potential. We need to get below that 0 point. What we need to do. That 0 point, how can we? Because that's on the other side of the boundary. I don't think there's getting past, the 0 point in this case. But the atmosphere, the the dielectric. See, in every electrical circuit, it's the inductance of the wires, which is powering the load. The energy's coming in right from around the ambient area, just like that heat exchange. The only thing the generator's doing is energizing or polarizing it's polarizing the conductors, energizing, and it's sending a signal down the line, a metaphysical voltage signal, which I don't know that signal's even coming down the line. We're spinning a magnetic field back in the generator, right? Whether it's a permanent magnet, whatever it is, electromagnet, whatever, one of the two. There's no magnetic field manifesting just when we're spinning. There's a difference of potential between the terminals, but there's no magnetic field manifesting until it comes into contact with the load, until there's reactance with the load. So I've been, on this rant about how there's no magnetism manifesting around the conductors of an open circuit. Well, nor is there any voltage signal, because before we can get a voltage, now the potentials is there between the two physical terminals. The potential most definitely has to be there. And, once your frequency gets so high and your voltage gets so high, it'll jump the gap. So, and we're dealing with two types of reactants. We're dealing with capacitive reactants of the dielectric medium, and we're dealing with the inductive reactants of matter. And, the inductance of matter, obviously, the bigger the conductors, obviously the more load you can put on. The more load you got on a circuit, the bigger conductors you need, right? That's because the bigger the conductors, the more magnetism, the more inductance that can be stored. But anyway, so long as you get that the energy is coming in right from around the ambient area of the load and the conductors, right there at the terminal. The generator is just serving to polarize or energize the conductors, which have a loosely bound outer molecular structure. What makes a good conductor? It's not reflecting. It ain't conducting the fucking thing. It's reflecting until the circuit's put under load. We just got a reflection. It's not allowing admittance into the conductors. And what about this thing about a dipole antenna? Once that voltage signal leaves into that dipole antenna, where in the hell does it go? Because it ain't got no magnetic transverse component. It don't travel transversely through 3 dimensions as we perceive it to. It's it's longitudinal metaphysical displacement. It's instantaneous action at a distance. It's instantaneous action at a distance. It's a longitudinal displacement or scalar wave. Which how in the hell is it a wave? It ain't no wave. That's neither here nor there. It's a scalar potential. Okay, and we have alternating scalar potential in a alternating current circuit. We have alternating. Like I said, I don't know. There's a potential there, but before we can even read a voltage signal, we have to come into contact, make reactance with it. Is what I'm saying, ladies and gentlemen. So, we get this picture of a voltage signal, and it's sine wave, sitting there oscillating. That, yeah, there's a potential there between two terminals. But before we can even tell it's there, we got to come into contact with it and discharge some of it. There has to be a reactance. Just like before there's any sound, there has to be a longitudinal metaphysical displacement in the open air medium. And before there's any sound, it's got to come in contact with the matter of your eardrum. Okay. Now, how do we get in resonance? Now an example of acoustic resonance is destructive. In destructive variety is when you see, a woman scream and she breaks glass. Well, that is a destructive resonance, right? And I imagine that, and what the university professors, all the university professors, the problem is this, is there's an erroneous presupposition that they're particle theory, that they're shooting no balls of particles at the affected area. We could advance, the electrical science, all the secrets of the universe lay within a more thorough study of the electromagnetic science. Because, like, again, gravity's not over here, electromagnetism over here, and strong and weak nuclear force somewhere else. It's all the same. It's a dielectric medium. Different modalities of dielectric medium. It's like ice, water, and steam are different modalities of the primary element H2O. So, anyhow, so now I explained to you force itself. When we're standing on the ground, gravity is electrostatic acceleration back to the point of zero potential. So is magnetic attraction. That's dielectric acceleration, not towards one another, towards the point of zero potential in the ether. That's dielectric acceleration. Okay. Now, now between the top of your head and the ground that your feet are standing on, there is a difference in magnetostatic potential. Right? That's what causes that force on it, drag on it. Physical matter is what causes, we wouldn't have to deal with time if it wasn't for it, just like that rotor. Just like that metaphysical voltage signal that's oscillating on the stator. It ain't got to deal with time because it's metaphysical. It ain't got nothing in 3 dimensions. Let tape measure on. And so, well, that's what creates time itself. Space creates time. Now, you should have been able to see that in the example that I showed you. I showed you a linear example of it. By, when we knock in a single phase motor, we have to use a capacitor to retard the field, knock it out of phase. Now, I've already showed you this a couple times, but I'll show it to you again. And I'm at 28 minutes, and I don't think I'm getting it up or not. So anyway, let me just show you once again now. Now, this should show you how space and time are essentially linked. Okay. Now, this is single phase motor. Now, this is one coil. We have 2 coils, 2 windings here. These are just, 180 degree displacement between each end. So this is positive and negative and north and south. Because remember, the electric field or the electrostatic field and magnetic field are 9 degrees out of phase. So if you imagine riding a merry-go-round and being on the outer edge, that's centrifugal force. What's responsible, what magnetism is actually, the centrifugal force, divergence away from, out into 3 dimensions. Okay, now, when you're standing on the outer edge of the merry-go-round, that's where you can feel the force. You can feel all that force out at the outer edge. Now, I want you to visualize a copper bar down in the ground. It's grounded at one end because it's bonded to the ground. It's drove down in it, and obviously it's hanging free at the other. Right, just like his stator winding I showed you. You know, so imagine what would happen if you would grab a hold of that bar while the merry-go-round was spinning. Well, it'd pull you off at the right fucking angle, wouldn't it? Excuse my mouth, but it'd pull you off at the right angle, right? It'd pull you directly off the merry-go-round at a right angle. And that's what's happening. That's when magnetism appears, when we reach out and grab hold of that bar, and we don't reach out and grab hold of it. The generator don't reach out and grab hold of the stator until the terminals at the load, till the switch is closed at the load. Until there's a load to react with, the magnetic field in the generator don't even reach out and grab those windings, because there ain't no reaction in the circuit. So anyway, now what's going on here is so now we're being fed with a single phase supply. We got, whether it's 240 volts or 120 volts, it's still a in phase voltage, because it's 180 degree displacement. So it's in phase. It's an in phase voltage. But in order to create a 360 degree rotational torque here, we need a phase to phase voltage. We need a phase angle shift, so we need to knock it out of phase. And if we ain't got a supply that's got a phase to phase voltage, how we how we do that is with a capacitor. Now, obviously, this capacitor has a certain amount of space between it. And so it takes this capacitor a little bit amount of time to charge up. It takes the capacitor time to charge. Just like in the other example I showed you with, I can remember where it's at. It takes a gallon jug, a gallon reservoir I'd cut into a water line. If I had show you the example again. So if you could just imagine a water pump, right? And then we got one line going out. We tee that line off. We take one end through a reservoir. I don't know, whatever, how many ever gallon, 15-gallon reservoir. Okay. Then we go out to a spigot. And then the other one that we teed off, we take and go straight on to our termination point at the spigot. Now, both spigots are the same distance away. Right? But which one's going to get to the termination point first? Right here. Now, which one's going to get to the termination point first? Right here, what I'm demonstrating. Well, obviously, the one that ain't got to fill this gallon, this reservoir up. Now, I said the magnetism reacts back on a loaded circuit in the same exact manner that a water tower reacts back on the conductors. When the water lines lose pressure, that water tower will react back to create a force when they lose pressure. Lose the pump, whatever. The water tower will react back to pressure like that, pressurize the lines. It'll induce a voltage, so to speak. And that's the same exact way this magnetic field reacts back on the conductors of a loaded circuit. Okay, but it don't react back. There's got to be reactance. There has to be, physical reactance with the load. The switch has to be closed. The circuit has to be closed. There has to be a reactance of a metaphysical voltage with a physical rotor. And that knocks that potential out of phase by 90 degrees. And again, what creates a good rotor is the inductance of the rotor. You want to ferrous metals have a higher inductance, right? And what that means is they can store more magnetism within their intermolecular structure. They can store more the more inductance they have. But there's a point that the material gets saturated and can't store anymore. And at the point of saturation, obviously, it reflects. It reflects back out as magnetism. 90 degrees out of phase, obviously. So it's 34 minutes, hell. So anyway, now first before I go here, now why can we not just simply, we've got a phase winding and we've got an auxiliary winding, right? Now, why can't we just take a neutral? So L2, why can't we just go to L2 and auxiliary 2 with a neutral, and then parallel auxiliary 1 and L1? Because they'd lock the rotor dead. They'd lock it dead in place. That's what it'd do. It wouldn't move a bit then. You know, we need two signals. We don't need them right here at the same time. They're both at the same potential. They'd both be at the same potential, so it locks the rotor. But however, what we do is we run it through a capacitor. We branch the one hot off, just like going through the reservoir with the water line. We go through a capacitor with one of our hot conductors, and it takes time. It takes time to charge that capacitor. Now, the further those plates are together, the longer it's going to take to charge it. The more space. See, we got a spatial displacement in 3 dimensions is giving us a metaphysical displacement in time. So we have created two signals because we've used a capacitor to knock this 180-degree in-phase displacement out of phase. You understand that? And in order to induce 360 degrees of rotation, that requires a phase-to-phase voltage, a phase angle shift.